Okay, so hello everyone. I'm very actually happy to be here. This is the first tutorial I'm doing for FAIRmat, so it's kind of exciting for me. So my name is José Pizarro, like Lucas said, and well, you can also call me Chema. This is like a more actual friendly way of referring to me. So how we are gonna schedule this tutorial, you can find it actually in the website of the tutorial itself. There is now an updated schedule. So first I'm gonna talk for about, I guess at 30, 40 minutes, I guess that will not take the full time about these very basic concepts that Luca was telling you about. Then Nathan is going to come after me. Then we will do some break, and then we will repeat this kind of flow. No, first me, and then Nathan. And yeah, feel free to stop whenever you feel you have a question or you feel that I didn't explain something very well. Just I'm pretty open to interruptions, right? Okay, so actually the website was also updated with a new tab, a new menu called materials. And because we prepare essentially a whole kind of documentation or like set of instructions for this tutorial. So it is divided in parts. So this first part that I'm going to talk for 30, 40 minutes is in this two actually. Then is Nathan talking about part 3. I come back part 4, and then lastly we finish with part 5. And even if you are not here, and then or you lose some, you get lost in some points, everything is explained here, so you can come relaxedly, try yourself later on, and so on. No, I think we are gonna probably I will come back, and Nathan also will come back to these kind of notes at some point later during the tutorial. But in my case, I'm gonna actually go very hands-on. So yeah, feel free to follow or just check what I'm doing. And I'm going to start actually trying to go into the NOMAD page, which is kind of the first task that we should be doing. And here you're going to find, so for people who already work a little bit with NOMAD, this has changed. It's a bit like rework and a very much nicer, I think, layout. And here I just want to mention that currently there are like two main versions of NOMAD right now. One is the one that happens when you click this Open NOMAD, which is more like a stable version that keeps updated like every 3 weeks or so. But because we are now talking especially about latest developments, we are going to actually go to another more like updated version, which is the beta or the staging version. And this one can be found actually at the very bottom of the page here on the bottom right now. Let's see beta staging. So once you click there, you should actually go into that version, and then you will see the latest changes and so on. Actually, there is a third version which is hidden, and the fact is that because there are a lot of changes that we have been implemented during the last months, and NOMAD contained. You heard from Luca, no? That NOMAD started in 2014, and then so the data that was already there needs to be reprocessed somehow in order to allocate for these changes, right? So out of the 12.5 million data points or entries. The new meta info, so the new metadata structure has to be populated, and that's why we are currently reprocessing the NOMAD archive. So don't get scared if you see some zeros like or something that is not populated. It's just that we are just trying to reprocess all this whole thing. Also, don't get scared if you see these errors. This might be because we are in the beta, and that implies that we have somehow like this is expected, I would say. In this case, it doesn't affect what we are going to do, and it's fine. In any case, so when you click in entering either in the stable or in the beta version, when you click, then you will end in this kind of what is called the entries page. It's a graphical user interface that we have in NOMAD, which I think is very nice to see, to visualize the data and try to find the data initially when you want to search for something. No, in this case, is each data point or entry, how we call it, can be found here in this card. There are some set of menus that we will visit through this tutorial, and actually there are some filters, and the keys on the filters. No, so when you are trying to find some kind of data, you can filter depending on the system that you want to study or material you want to study, and yeah, you can specify which atoms from the material, which structure you have. You can also further specify like the methodological parameters. This is mainly currently a computational side, but you could also think like experiments could also have like their own menus here. No, I think Nathan is going to come and speak a lot about this precision menu here, and in my case, I'm going to put the focus on these 4 menus. No, in GW, in BSC, in projection, and in PMFT. Okay. Besides this kind of two, so material, so which is the material and what are the methodological parameters you are doing in your calculation, then there is also like a set of output properties that you can find. So let's say that you want to find a specific material with some specific band gap, then here you can actually try to find it, put in this filter. So you can select like, I don't know, I want something between 0 and 3 electron volts, then it will, the system discrete will react, and then it will just show you on this new method, it will show you only the materials that contains this property. And I think this is really valuable. It's really nice to be able to have like such a reactive thing. In this case, this is how you normally do it. Then I will just explain you a little bit more in details how you can query in a Python script and so on. But for now, this is it. You can play with the menus and try to find yourself what you want. In this case, just to put a bit of the focus, that's why I tell you don't get scared if you see too many zeros. Just let's take a look on these menus that I was trying to implement. So in the case in GW, it's mainly like the experts on each of these techniques will probably know what these quantities refer to. So if people knows about GW, you know that there is the type of self-consistent cycle that you follow in GW, and then they have different labels. So the thing is that every time you put GW data in the archive, then this will be recognized, and then it will just populate, it will just include like a +1 in the corresponding quantity section, right? Same goes with the starting point, which I guess you can imagine this is related to the strength correlation functional you do in DFT, and well, for basis setup. There is a set of menus, so this is continuously being developed, as you can imagine. So again, too many zeros. But these kind of menus are continuously being developed. So in every time, whenever you feel that something is missing, or you, let's say, as an expert of BSE, of the Bethe-Salford equation calculations, you feel that there is a quantity that you are always searching for, then please feel free to contact us, and we will be very happy to help you, to implement this for you, and then you can later use it. Here again, I didn't mention it before, but once you hover with the mouse over the specific quantity, then it gives you an explanation. The only thing here is that these menus essentially show some quantities, but doesn't show the full parse quantities that we treat in NOMAD. So essentially, whenever you have some files and then you upload it and then you publish in NOMAD, then there is some processing happening, and then there are some certain quantities being populated. And these ones that you can see here in these filters are actually just a selected set of those, just the more used, like some strings or probably some simple zero-dimensional float number or something like that. So it's easy to, like in the case of the backup, so it's easy to search for them. But the full set of definitions, so here in this menu, if you now go to analyze, there is something called the NOMAD meta info. And this one is the web that contains all the NOMAD defined quantities. It looks a little bit scary, but I have to show you this because later we're going to try ourselves some data, and then we're going to see which kind of these sections quantities are being populated or parsed, right? So for computations, the most important ones, well, apart from general metadata information, this contains things about the upload, so IDs and author names and so on. There are three main sections that are important in a computational data set in NOMAD. It's run, workflow, and results. Okay, and run is the one that actually contains all this kind of parse data into NOMAD. So it has things like what is the program that you're using, so the name of the program, the version of it, times, possible messages that you want to store, and then most importantly, it has like kind of three main subsections which are called method, system, and calculation. If you see in the when I was showing you the GUI and then I was showing you the filters, this is also kind of the same structure. No, you are always you will always like to find like which kind of system of material you are searching for. So what are the methodological parameters that you have that you want to input in your calculation, and also which is the output of that calculation. Okay, so you know this input, and output. Okay. And so, for example, if you go to method GW, you will see that now instead of only like the self-consistent cycle or the starting point, there are much more quantities being defined. So the whole idea is that you first filter the data somehow, and then later you can further operate with that. And I think I will show you later, like, well, I think I will not show you in this case, but this is the whole idea of NOMAD. No, we filter first, and then we further check, trying to search on this, run certain parameters. For example, now you want to search for the k-mesh, some specific k-mesh, then you have to later on doing this. No? In any case, run is not the one that is actually connected with the GUI, but in NOMAD we have another section which is called results, which is trying to map these part quantities into kind of like the one that is connected with the GUI, right? So results is actually the mapping from run into new sections, and then this one will be then later connected with the GUI. This you can find again like this kind of three legs of NOMAD, so material, method, and properties or outputs, right? And now if you now go into the simulation and so if you go to the method and then you search for GW, now you will see that indeed these ones are the ones that are like in the filter menu of GW. No? So the type, and by the way, I didn't now wanted to show you that actually there is a whole description of each of the quantities with. So the better the description, the easier to understand. Now, so in this case, I think it's pretty standalone to see that what is this GW, and even with references and the further explanation of these streams. Yeah, so this is like kind of what is called the NOMAD meta info. The last thing I want to show you before breaking into the second part of this first block of the tutorial is that actually once you select a set of filters, so let's say that we want to find some GW calculation which is based on some DFT data point. In this case, it's only one data set, but okay, it's gonna be so one data point, sorry, but it's gonna be later more. We can, in this case, specify that it's silicon and so on. But the important thing here is that actually everything that you can do, you can actually also search via API calls, like a fast API calls, meaning that you have to somehow query this data in a Python script that you write yourself. Okay, and this is something that I'm going to show you at the very end of this first block. There is a lot of documentation, even a dashboard if you want to play with these API calls. In my case here, I just also wanted to show you that the query data is just essentially like, okay, GW0, W0, LDA, and silicon, but it's just being resolved from some results dot whatever section and whatever quantities. Okay, that's why it is connected directly with results. Yeah, so this is kind of like this part one I was explaining you here. Now I will just try to explain you what happens, how to do an upload, how to try to understand the data that is parsed and so on. So if you have any questions now, you feel free to interrupt, because I think it's good to have like I think Nathan said it before, it's good to have like a slight mental break and try to understand what I said. If not, I continue in a couple of seconds. But okay, then if nobody says anything, nobody unmutes, I don't see anything in the chat. Then what I'm gonna show you now is what happens when you want to, how to do an upload and how to explore like what's happening for that specific upload that you are doing. And for this case, I'm just gonna be super simple. I'm gonna take something that is already in NOMAD, and then I'm gonna re-upload it into my account, okay? In this case, so this is the GW calculation I was searching for before. I just click, sorry for this. I just click here in this arrow here, which is go to the specific entry page. And essentially you will land into an overview or a summary of that entry. Okay, in this case it's silicon with some composition, symmetry, lattice parameters specifically. So it's bulk silicon. There are some information about the methodology, the program follow, and these things, and some properties that you can see. We are going to come back to that later. And then here in these menus, you can actually check the files one. And we are gonna, if you want to follow, okay, if not, just check what I'm doing. It's just about downloading this folder and then re-upload it into NOMAD. Now this will be a zip files, which are zip file with all these files that you see here. Okay. Now in these menus on the left, so on the top left there is this publish button, and then here we're gonna try to upload this data. And for that, first you need to be registered. I think this honestly takes almost no time. As you see, there is not so many information you have to fill, mainly the email and the correct password, right? And but then I'm not going to do it, of course. I'm already registered into this, and then we're going to try to create a new upload. So in this case, well, once if you're registered, this is what happens. You do that in this website, and then we are going to try to create a new upload. Here you can actually see all the uploads and published data that you have in Nomad. So normally when this icon here on the right is blue, it means that this data is published. There are different means for this, like this group of people. So you can actually extend, so you can name other collaborators into your upload to see the data and to see that everything is good or not. I think that's also helpful when you are like doing research, right? And then later, if you want that this data to be published, you can just press the button publish with some given embargo of days or months, or indirectly publish, like you prefer. But if you create a new upload, actually, and this is the thing that convinced me to use Nomad myself, which is that Nomad actually works in a drag and drop or like a kind of system. So you only essentially need to get your files from your computational data. Okay, I'm gonna have them here. This is I guess it's a little bit small, but this is the zip file that we just downloaded. And then by just simply, either exploring the directory or just dragging and dropping it down, then a processing starts. And if the feature and the program is possible to be parsed, then this will like pop out the correct information. Now, in this case, again, this is a GW calculation. So first, so it's silicon. So first, someone did like a DFT calculation, and on top of that, that person did a GW calculation. And this in principle, so here it is generating. So this set of files is generating actually 3 entries. Mainly the single point. So whenever we call something single point, we call it like the most basic unit of information. And I will come back more in detail later when talking about workflows, in the second block of this tutorial after the coffee break. But the most simple piece of information, which is the single point, is okay. I'm gonna do like one singular calculation and then another singular calculation, which is either DFT or GW. And then in Nomad, it's possible sometimes to actually recognize this kind of, let's say, workflows when we are talking now. So first somebody did a DFT calculation, then somebody else did like this on top of it, like first DFT, then another excited states methodology or not. And in this case, because it's implemented, then it can be recognized by Nomad, and then Nomad will generate an extra entry in which it puts all the information from both single point calculations together. Okay. Anyways, don't get confused. Just like I'm going to come back to this in the second block. In any case, you can actually now, well, if you go further down, you can edit the author. You can edit the author metadata and then publish, like I said, publish with an embargo or not. No? In any case, you can explore also the individual entries to see that everything worked properly. So I'm just going to the DFT and checking the overview page. This is the same overview page or summary page that you find when you browse through the archive, in a specific entry. And then you can see that there is some silicon with some DFT reports that it has a band gap of 0.44 with the band structure, the density of states. So depending on the calculation you have, it will probably show different properties. So if you have a phononic calculation, then probably you will see some phononic dispersions and so on. It pretty much, now we are talking about electronic structure, so it is electronic properties. And what is important here is to show what's happening. And for this, I'm going to actually go to the GW because I'm going to talk about excited states. And then apart from files, I didn't mention these logs will tell you whether there was some issue in the processing of this data. Everything was successful, so you shouldn't see anything of an error or a warning or something. So nothing happening wrong. And then the most important menu here is data, which is actually this Nomad meta info that I showed you before, but only with the specific sections being populated. So there is not any extra complicated things. You still can actually see that information. You can actually see that information. You can see what are all the quantities and all the sections defined. So you see here that only the ones that are bolded are the ones that are being populated. And well, I'm just gonna plug toggle the click of this menu here, and then just show you that indeed this was successful on parsing GW as a G0W0 calculation. Then there was some analytical continuation using the PADE method and some other more information about the calculations. Okay, also with the definition of the sections and so on. So lastly, I just want to mention this called a specific button here, although I think Nathan is going to talk a bit more about this. But essentially, in NOMAD, we made a little bit of a difference between very core specific quantities and quantities that belong to a kind of higher class, let's say, or quantity. So, for example, meaning that the type of DW calculation is something general enough and doesn't matter which code you are using. But maybe there are other kind of inputs that are not so much clear whether it belongs yet to something more general or not. No? So the idea is that anybody that knows about this specific program, which is exciting, then they see this core flag equal al, and then they understand it. But then people that doesn't know about exciting, they don't need to know what is this flag, unless at some point then this evolves into some less core specific quantity. No? So this is part of the development in which we are working right now. And yeah, so this is for the upload of data. It's very easy. Normally it's more involved because I guess that people have very large data sets. So sometimes you have to break them into parts and upload the data into NOMAD. Be careful. And even later, I'm going to try to talk with you about how you can prepare your data even in a more friendly manner. So these kind of workflows, for example, these kind of extra entries are being recognized by NOMAD, and then you don't need to do anything yourself, let's say. In any case, now at this point, I'm gonna go into the web again. Now that we have uploaded the data, then you can publish the data whenever you want. Now I'm gonna show you how you can actually query that data using this API call. Okay. And for this, if you go to the tutorial page, apart from the documentation that I was showing you before, you can find a Jupyter notebook. You can click on it, and there's I'm going to follow the FAIRmat tutorial 10. There is also it's a server that contains the environment in order to be able to run these things. But if you click start, then the environment will launch, and then we can I can show you how to query. Like in a Python script, these are around 3 lines of code, and I think very easy if once you get a little bit of knowledge of NOMAD. So if you open this, now what is going to be the objective? What is the objective of this notebook? Is we are going to try to find this silicon data, this DFT and GW data, and then I'm going to try to plot the density of states for both of them. And then we should actually see that the band gap in the case of the TW is bigger than the one in the DFT. No. In any case, this requires that you have. So there are different options when you want to query data in NOMAD. Here, I just went to the simplest one, which implies that you have to install the NOMAD package, and then you just have to import this archive query, which surprise is just querying a NOMAD archive and then retrieving it as in this NOMAD meta infrastructure, right? So in order to do that, you need to define mainly two dictionaries. So in Python, one is the query, which, if you remember, I already showed you when you press this button in the filters, is what can be extracted. So this you can essentially work in the GUI in this entries page first, clicking your filters, and then come here and copy paste that dictionary that you want in there. Then it requires another dictionary. In this case, we want to retrieve both the section results and the section run. And then because we are targeting the beta, we have to specify the URL of the beta. If we are in the more stable version, we don't even need to specify this URL here. In any case, you can actually run this yourself if you want. In any case, by just this very simple line of code, so archive query, and then there are more options to this, so you can actually visit the documentation upper in this document. You have a documentation page, so this Python package query process data or using the APIs. It will take you directly to the NOMAD documentation explaining how to handle these things more in detail. But for us, it's enough to just simply do a very easy thing. So there are more options here that you can specify in this class. You can actually further specify how many of these entries you want to download to be retrieved back. In this case, it's only going to be one, but if there will be 10,000, then you have to make a decision here. Then it will start fetching this data, and then it will download it, and it will retrieve a list which is called entry archive. And then if you remember from before I have it open here, then now we can access all this information by just saying like this entry, so this archive.run method, and then we can access all this kind of information. The one that is important for us, which is the density of states, well, you can actually also like print the archive if you want, like in a more like a JSON style. So here, for example, we can see that this is exciting calculation, information about the positions of the atoms, etc. But in our case, we are just going to resolve the density of states, which is contained in this kind of path over here. So archive, it is in results, it is in properties, it is a discrete property, and then it's total. Okay, and this will actually give you back a list. Okay, that's why you will see a list of two elements, two types of density of states. One is the DFT1, the other one is the GW. In any case, you can actually print the label of each of them and then check that it is indeed that. So it will just give back here like a string, which is DFT or GW, not depending on the other thing. Then, by just doing using matplotlib, I just did this plot over here. In blue, you can see the DFT density of states, and in orange, you can see the GW density of states. And you can see that when you, well, this is something now, so in GW, when you include the screening in a more meaningful way, then you will see that the bank gap, so the bands get like a little bit of opening of the system. I think with this, you can also calculate the bank gap, and then it will retrieve like a number which is in the GW case is bigger than in the DFT, and it's even more comparable to the experiment. So you could even think like about when the data is present, you could even think about like, okay, let's do like an automatic like querying of a lot of data, a lot of type of data in NOMAD, and then let's retrieve the bank gap and let's compare, for example, with my experiment, or let's do some other stuff. No, for these notebooks, you can also use it for machine learning and so on. And with this, I think I finished. I don't know if I hope I didn't miss any kind of important information. I hope this was not very complicated. So this first part for me, it finished. I promised like not 40 minutes, so I took like 27 minutes. I'm checking now, so I hope that was not so fast. And yeah, if you have any questions or have any comments or something, feel free.